And we're live. Hello all, hello world. This is day 180 of studying compilers every day until I land a compiler role. I'm a little bit sleepy, so I think I might have to keep today's stream a little bit short. What did we do last time? Last time I think we finished all of the middle end plumbing for the most part. There's like one small thing we have left to fix, but it's pretty much done for the most part. Yeah, so the plan for today was is to fix memtoreg. Yeah, so specifically right now it's lowering everything, or I guess turning everything into a register, but we need some conditions on things that it can lower. Specifically lower, I guess raise, I don't know. I guess convert to register. Specifically if something is derefed, then we should not turn it into a register. Yeah, I mean, I think that's pretty obvious in some capacity. So yeah, I think that's probably gonna be all we do. I don't really want to do anything else. I think we've already done this though. Dead Lozen address. I think we already did that, but we'll have to double check at some point. But yeah, we're gonna need to. This is our primary focus, memtoreg. So yeah, here we are. Let's go straight into it. Okay, what am I doing? Let's get rid of that. Okay. So this should all live in the middle end in the transform. Let's look at memtoreg. So we insert fees. I guess we need to figure out which allocates we can get rid of, right? That might be a cleaner way to structure it. And I'm starting to realize that we're gonna have to do a lot of stuff in here. This is a giant, like, what, 150 line function? That's not gonna be fun. So we're gonna need to figure out what the hell we're doing. Yeah, so we compute dominance frontiers, that's fine. Oh man. What do I even do here? I'm so confused. So we have all the defs. I guess that makes sense. Yeah. Yeah, I'm quite tired. I don't remember what I was doing here. So for each instruction, oh, let's go 360 sauce. Good to see you. So for each instruction, we check if it's a store. Oh, I see. These are the okay. Yeah. Okay. This makes complete sense now. So this is we literally just gather all the defs here. So now we insert all the fees. Yeah, this is fine, I think. What happens if we just ignore the fees and we like come back to this if we need it? We should definitely mark things somewhere. Yeah, this is confusing as hell. Yeah, okay. I guess we should probably like traverse everything here first. So this is mark non-lowerable. Not, or I guess mark stat, or what do I call it? Is this lower? I guess non-regable LKs? I don't know. I guess we'd probably do it in defs anyway, right? Because we'd look at it here. What's good, Rehan? Are you making a C compiler? Yes, I'm making a compiler from C to x86-64. Okay, well let's take a look at how we make the address instruction again. I believe this is an HR to MIR. So if we scroll through here a little more. Okay, here we are. Okay. I see. So it's literally just a load, a pointer type load. I guess we could look at all the loads. Yeah, that might be a way to do it. So we should look at all the loads, and then if it loads from a pointer and that pointer isn't alloc, then we should not lower that. Is it specifically just allocs that we care about here? We could try it out like that for now. Let's just stick it in this loop as well. So here I guess mark defs, and then we should mark addressed allocs. So we should yoink that. So this should be load, or I guess like Azure s of. I guess we could make this a load as well, or we should make this load. So load, then if not load, then continue, maybe. Aye. Oh my god, I can't type. Okay, today is going great. Alright, we can do that. So now we know it's a load. So then if load, so you want to get putter. So what is the pointer, I guess? Do we care if it's not an alloc? Yeah, wait. I guess we only care about allocs for mem to reg, right? So I guess literally just if that, I guess if, so we want, I guess, alloc, we would just want, we want a dynamic cast again, instead of that should be alloc, this should be load, get putter. So then if alloc, then we can, yeah, if it's alloc, then we should add it to a list somewhere. So like std unordered set, I guess? Multi-set. Wait, what? Okay, so we do have set. I'm just going insane. So on that, and this is unlowerable. Yeah, so we could call it that. So unlowerable, we want to insert alloc. Right? Yeah, okay, cool. So now the question is, what do we do with unlowerable? I don't know what to do with unlowerable. I guess we could figure out what to do in fees later. Let's move real quick. Let's move this comment down to here real quick. So compute dominance frontiers, and then here we get all defs and mark unlowerable allocates, I guess. Well, that hopefully will make things more readable when I inevitably have to go through this again. Okay, so now we'll skip fee insertion stuff for now. Let's just check variable renaming. I'm not sure what I'm doing here again. I guess we could just like, this is very confusing actually. Okay, so what is this fees set again? Let's go def everywhere. Can you tell me how to start learning this? I have a list of recommendations. Hopefully the bot works. Okay, so this fees map maps, and wait. So it maps a basic block to, wait, what? What am I doing here? Oh, I see. It's per allocate. Okay. That makes a lot of sense actually. So then we should probably skip some things in here then. So we have, okay, so we have all of those. Do you only have basic block support or global optimization with super blocks? Right now it's just basic block level. Or I guess like my passes run just at the entire program translation unit level. But all my passes right now are kind of simple. I want to do more with it though. Good luck on your internship. Can you give more details? Not really, to be honest. I'm still waiting to be onboarded for the most part, but it's at a local trading firm. They've basically given me an opportunity to just mess around with their compiler toolchain, so it should be a good time. You should make videos about the recruitment process. I'm not sure. We'll see. I'm not sure how much of that I want to share, let alone I'm even allowed to share. Yeah, again, I'll come back to that at some point, but it's not really a priority right now, for better or for worse. Okay, so let's actually swap the order here. Okay, so then let's do it like this. And then actually no, we should just like do it the other way. It really does not matter. This will simplify the code a little bit. It's a shame you can't directly share, since people who come would definitely click on a video summarizing the process. I guess maybe, yeah. I don't know. I don't particularly care about clickbait. I don't think that's a lot of fun. I'm just here to write code, to be honest. I'm just here to write code and like do a little bit of work every day and just build up to something cool at least. Okay, let's look through this again. So what is defs again? I see. So we try to insert a fee in each of these. So then if, so what type is allocate again? Is this an allocate pointer? Oh my god, this is really annoying actually. Okay, let's get rid of that instead. Try that. Okay, well, okay, so we know it's an allocate pointer, so we can do unlowerable, contains alloc. So if that, then we continue. We just skip it altogether. So we don't care about fees for that, and everything is fine. Okay. I see I have multi-level IR. If you mean like I have multiple IRs, like yes. I think that's like the only sane way to go about compiler design, at least. Hey man, discovered you by the Algo Gods. Good luck. Good work. Thank you. Yeah, welcome to the channel. Hopefully it's a good time for you here. Okay, so we're gonna need to do this this skip thing a couple times actually, which is gonna be a little bit annoying, but it'll be fine. So alloc, if unlurable contains the alloc. Okay, so this goes through the work list. Yeah, so this like propagates backwards, I believe. Okay, so we get the reaching definition. I'm not sure if we skip it here, actually. I think, that's really confusing. So the fees of the basic block. This shouldn't happen anyway, because this shouldn't be added in, I believe. So this should be fine. Should not have unlowerable allocs. I guess we could safely assume no unlowerable allocs. We're gonna need to re-ink this, but that's fine. It's crazy to think about how still in today's age we're mostly converting semantics just to SSAIR. I mean, yeah, it's pretty powerful. I think there's a lot of stuff that's left on the table still in terms of like what we can do with SSA. Hey bro, Brazil here. Ooh. It's always really fun to see people from around the world. I don't know. It's a lot of the interaction I have is mostly from like people that grew up in the US at least. I don't really get to talk with a lot of people around the world, so it's always really cool to see chatters from everywhere, I guess. Okay, let's do it like this. So now we're just looping through the basic block and replacing uses, I believe. Right? So we start with the entry block. Yeah, I'm struggling here. I guess. I can do this. Have you looked into the obfuscation? I haven't actually. I don't know. I haven't really had a reason to. It'd be really cool if I had the time for it though. Oh wait, we can't do alloc here. I think we should do putter, or we'll figure this out. We can do a little casting. It'll be fine. We'll just have a lot of dynamic cast, which is very unfortunate. I want to do fast dynamic cast eventually, but it looked like a lot of work, so I don't want to do it anymore all of a sudden. Yeah, okay. So actually, let's just not do this at all first, and let's see if this works. And then we'll see if we need to add additional stuff in. So just join what you're doing specifically optimizations. So taking a step back, I'm making a compiler from C to x86-64. Very recently I added just like basic memory operations, so specifically like pointer types, the address operator, and the deref operator. Right now I'm fixing my middle end passes because they did not assume pointers existed before. And that causes a lot of interesting problems. So like specifically memtoreg right now, it's like nuking a bunch of allocs. So I'm ending up with like some null pointers here and there. And that's causing some problems with my printing at least. So if we're getting the address of a stack variable, it probably shouldn't matter anyways, but just for the sake of the compiler not crashing, I think it's important that I at least fix memtoreg. It is like technically like valid code, even if it's like unsafe. So I think my compiler should be able to support it at least. Is that C or C++? The project is written in C++, but it is compiling C code. Okay, so this is the test, or I think this was the test I was looking at. So build bin panic test regression input putter. So if we do O0 and then like emit MIR, which is our optimizer language. If we look at putter, yeah, so this all looks fine. So now if we run it with O1, or I guess it defaults to O1, we segfault. And if we valgrind it, I guess this means that still doesn't work, but where's this going wrong again? Yeah, we're in memtoreg, and we are looking at I believe we're looking at something wrong with the bracket operator somewhere. I think something with the reachings. So I think we do need these guards specifically. Yeah. So we don't want to mess up the reaching definitions. Or like we don't want to load like that. Okay, so we have load. So then we should paste that again. So an auto alloc equals, we want a dynamic cast to alloc star. And let's give it load. We want to get putter. Yeah, so we can look at that. And this should just like stop. This should just like stop everything from quitting. Oh, why is it so slow? I don't think it's supposed to be this slow. Uh-oh. Okay, that seems wrong. Okay. Okay, I'm starting to think it's infiniting somewhere. Performing any sort of stack collapse optimization. I don't think I'm doing that yet, at least. I guess I'm generating code like the traditional LLVM front end way, which is just like, just make everything a stack variable and then run memtoreg. Yeah, I'm not sure where this is infiniting. Am I like missing a continue somewhere? Oh, do I increment iter at all? Wait. Wait. I see. That might be what I'm forgetting to do, actually. So let's do that. We'll actually just we'll just paste this in very boilerplatey, for better or for worse. LVM will automatically handle that. Maybe I'm just not understanding what you mean by stack collapse. Let's rebuild and try this again. I think we're just not progressing it, which is why it's infiniting. Well, okay, we're segfaulting still. Is this in the same place? Yeah, this is in the same place, huh? Replacing uses in a store. This is where running a debugger would be helpful? Yeah. I probably should step through a debugger. Let's try to narrow the problem first though. I'm quite lazy. You will find out that I will like, the more you watch me stream, the more you will realize I kind of just bend over backwards to not use the debugger because I'm quite lazy. Stack collapses and freeing RBP. Oh yeah, I don't use the base pointer. Okay, so even this segfault. Actually, why does this segfault? Yuck. The hell? Okay, 187. Wait. Wait, what? Huh. Okay, let's look at the O0. Or wait. Let's look at what it is before running memtoreg, because I think that's the first pass we run. So where could it be? I guess there are literally these loads, right? Let's try to narrow this even more. Int star address. We could be insane return address foo. Okay, this is marginally smaller, not by a lot though. I think we have a double store somewhere. I don't know. So now if we do this. Yeah. What the hell? Wait, am I insane or did we get more output somehow? What the hell? Wait, what? wait, what? Wait, how did we get here? Genuinely, how did we get here? What did I do? What the fuck? Okay, wait. I'm so confused. But this is so incredibly funny as well. What have I done? Yeah, this does not make a lot of sense to me. How is this going wrong? Wait. Wait, I'm so lost. Okay, let's get more. Let's be more primitive with this. Oh boy. Okay. Did I build just as a sanity check? Okay, I did build. Okay, this gives me something else to work with at least. I believe this was the first place that we were looking. Something like this. Oh man. Oh man. I added like too much random complexity into this and now it's slop. So it's in 187 again. So we're looking at the load, I believe. Right? I guess this is the only block. So I guess we could look at this more closely. So let's step through what we've done before actually looking at a debugger. So you check stores and loads. So this is a store. Okay, so that's a store. This is a load. So 4 is mark. Wait, what? Oh, wait. Of course it's an allocate. Oh, this is what we wanted to get rid of. I see. Okay, yeah, that makes sense. Oh man. Man, this is confusing as hell. What have I been doing? And we stored in 1. I don't know what I'm doing here. So we have that extraneous load for whatever reason. Oh wait, no. This is the deref proper. Oh man. Oh man. Yeah, virtualization is really scary to me. It's something I do not understand very well, and I'm trying to learn more about it this year. But like, there's so much to learn. It's all so cool. Yeah, I feel like every problem is just like abstraction and indirection in some combination. It's cool. Low type on %7 is wrong. No, putter is describing the type of 6. 6 is a putter. So like this entire line is the deref operator, I guess. Maybe I'm marking things wrong. Oh wait, yeah, then this is probably wrong. Wait. So we want the pointer and then wait. Oh wait, yeah. So if we want the pointer itself to be an allocate, or if the pointer itself is an allocate, then it's not lowerable. Yeah, okay, that makes sense to me. So that should be fine. Man. Okay, let's keep looking. This is fine, so we just skip the allocates that we can't do. And then we stick them on the work list, I guess. Maybe I just need to like add more guards, I think. I think this is safe as well. How are you determining if an allocate is promotable? I guess, yeah, first of all, I should rename this because it's promote, not lower. I kind of shut it out. Unpromotable. Second, I'm determining it just like if, it's all promotable by default, and, if we deref it somewhere, it's not promotable. I guess that's the only criteria for now. I'm missing the case where an allocate's address is stored somewhere. I see. Yeah, okay. That makes sense. So we should look at uses. You can deref it somewhere locally and can still become a register. Wait. How does that work then? Maybe I'm just not getting it, but Alex, 64 bits of data, deref twice. It can be turned into a register as long as the address isn't passed externally. I see what you're saying. I think I see what you're saying. Well, wait. Yeah, I guess local deref should be safe then. Okay, so then... No, I think I kind of get what you're saying. Yeah, I need to think about that more. I think, like, there's a more pertinent problem, which is, stuff is blowing up. So I need to be, like, quite conservative with this. So, I'll start with it, like, conservatively. Because it's just, like, my stuff is, like, literally segfaulting. But I think I could probably just, like, check the return pointer, and if it's an allocate, then we don't. Or whatever we load, and, like, if that's an allocate, then, like, we can't do anything with it. What am I saying? No, we can't. Oh, man, I'm tired. Okay. Lock in, twin. Yeah, so 3 is an allocate here. But wait, no. We need to check if it's a... Okay, wait. We should check the address case. So that's like a whole separate problem at least. Yeah, so let's just check that test. Yes, let's look at that. So in this example, 3 is a putter. So this should not, or wait, what? Yes, because this allocates a pointer. It's all so confusing. I don't know how to reason about this. What's good, Lane? Good to see you. Thunderstorm. That is rough. Stay safe. Wait, okay, wait, what is going wrong here then? Replace uses. It's like here. What type of compiler is this? It's a C to x86 compiler. Isn't it super late for you? It's like barely 11. This is like light work for me. I've been sleeping quite late. Emitting load putter for every load. The point. Wait, what? I mean, isn't that like what's supposed to happen though? Because the pointy type. I see what you're saying. Right now we're segfaulting without branching whatsoever. So 5 and 6 are correct. It's 4. Huh? Wait. No, the pointer describes what type this is. I think that's what LLVM does as well, right? And it looks like really ugly, but like we're loading from a pointer. So that type should be fine. It looks really ugly, but like putter describes what this is, which is a pointer. What's good, Aiden? Man, I'm in super hell. I don't know what I don't know what I'm doing here. I guess we're trying to figure it out, but like it is looking rough. Since 4 points to an I-32. Wait. Oh, I imagine it's with the old code then? I think that's where the confusion is coming from. Right? Oh, I see what you're saying. I don't think I encoded that in the print at least. Maybe I should encode that in some way in the future. Oh my, what? Okay. Caps lock moment. I mean, well, none of this is like solving this, or none of this is directly looking at the seg file at least. How is this even happening? Bracket operator. Yes. Actually, how does LLVM encode it? Because I tried to like copy what LLVM does, just so I could like cross-reference. And the idea was hopefully I could like reuse tooling, and then I didn't. Xerox 18, I see. Good comms. Do we have like a double delete happening or something? With a wait. Oh man, we're making a mess. Where can we add another guard? Oh man. Let's just count things real quick. Copy the uses list before iterating. No, this was working fine like on any other test for I believe. It's like if we just take some like random slop. This should work, yeah. Or wait, this is O0, wait. Yeah. So like if we look at this, like this is fine. Wait, what? Okay, so our block condition is wrong. Let's get rid of this first. We need that, the literal allocate there. Let's get rid of all of that. Yeah. So like this does what we want it to. Ignore this slot pile, but like this does what we want it to. Okay, wait. So this, I think this means we're being very aggressive with this. Okay, yeah, this is definitely like very dumb. Yeah, I think this marking is wrong. Yeah, I think I did this wrong. Let's What should the criteria for lowerability be? Okay, wait. So I want to get the pointer. So okay, let's load putter. I think I'm missing one layer of indirection. So what type is this again? This is a value. Are getting unpromotable instead of getting all promotables. I'm not sure what you mean by only load/stores. Because like when I initially wrote this, the assumption was everything was just a everything should be promotable. Because everything was just like a standard variable. So I'm trying to see if I can like work with this. You should only be memtorizing load/stores to allocs. If I alloc a stack var, then pass it to another thread, and well, we don't have threads yet, so like, or we don't have that level of mess yet, right? Like, I'm building this up like slice by slice, at least. Wherever you emit load for deref to use I32. Well, I don't know if I'm being like rage baited here. I think my print just does not show the load type. I genuinely think that's all that's what's happening. Like the type of this value is the type of like the pointee. It's just not like encoded very clearly in the print. I'm still trying to understand this like promotable versus like unpromotable thing. What's good, Savage Base? It's good to see you. I don't remember you, or I don't remember like seeing you on a stream before, but yeah, I guess it's good to see you at least. No, I know what you mean by like promotable, or like I know what you're talking about. I don't understand what the advantage of that is over doing like unpromotable. Like, what is the cost of doing it the other way? Oh, yeah, the reason I'm doing it the other way is because I wrote this with the assumption that like everything was promotable because of the, I guess, very limited language subset. It probably would be smart to like rewrite it to do like just promotable, but I don't think this is very different. Like I'd have to check the same thing anyway. We're just like inverting the logic. I guess what makes Oh, wait. I think I see what you're saying. We just check the uses. Wait, I should just be checking the uses of it. What the hell am I doing? Yeah, I should literally just check uses. Yeah, I think like even just like before the whole like the whole seg fault, I think I'm just like not guarding the right things. Yeah, I should just check this. I think allocates are, yeah, allocates should be instructions here. So let's check. Mark unpromotable allocates. I think I've encoded return as. Yeah. Wait. Yeah. Okay. I think that should be how I do this. So auto allocate star equals, let's yank that. Or let's yank all of that actually. I can't believe I just forgot that this is, yeah. Okay, I'm kind of just like chutting out. Okay, allocate. So then, okay, wait. So allocate, wait, uses, so let's instruction star, and I forget what the, how do I do this again? I'm forgetting how I like built my infrastructure because I spent too long on the back end. This is like really bad. I don't remember when I started the back end, but oh my god, I spent way too long on it. I do not know how to mess with the middle end anymore. Oh wait, we can just do this, right? Wait. Oh my god, what was I doing? You know what? We're gonna use this. We're just gonna we're just gonna do this. I think we need a copy anyway, so it's fine. This is so awful. I hate this. Okay. Aye. So let's do. So what type is this? This is a instruction star ref. Okay, great. That's not painful to read at all. So let's do load or use load. That's dynamic cast. Instruction load star. Oh, okay, that works. Hope it gets fixed soon. Thank you. I apologize if I was a little bit rude earlier. Or wait, what am I doing? This should be store. If so that so then unpromotable, then we can insert the allocate like that. There we go. And then we can break out of the for loop, and then we just skip to the end and life is good. Okay. Oh man, this is getting very messy. So then we can just, we have the unpromotable. I got rid of the unpromotable guards. God damn it. I guess we could start with this and see if it works. I think something's gonna explode, but everything's been exploding anyway, so like who am I to judge? Okay. Let's look at okay, that's fine. I guess actually real quick, let's check just like a normal test. Okay, so this is still fine. This is still perfectly fine. Oh. Wait. I think I know what's happening, actually, now that I think about it a little more. So... I think it might be easier to draw this out, because I think I understand it. Alright, let's hope this makes sense. But... yeah. Actually, wait. Wait. Okay, yeah, this makes sense. I could either... I'll explain the problem in a second. I can either be like really, really aggressive with what I allow to be lowerable, or I could do this correctly. I should probably do it correctly, but I'm gonna talk about this first. There's a chance that I just do it the lazy way and then just like chill for the rest of the night, but yeah, okay. So let's say we have, oh my god, this is laggy. Yeah. Okay, so let's say we have like this box, so this is like reg. Oh my god. Okay, why is this so laggy? Let's figure this out. Oh my god. Windows, please. Why is Discord taking up so much GPU right now? Okay, let's turn off shadow play. That should help. It did not help. Okay, this is great. Okay, well, we're just gonna have to deal with everything being a little bit stuttery for now. Okay, so this is like, let's say reg 1, and this is type like I32. We have another box here, this is type putter, and this is reg 2. So then like, let's say store like I32 like 42 into, well, we'll just be lazy. We'll omit the type here if we will undo fast enough. Dear lord. Okay, let's just say like store 42. We'll have some like handwriting liberties here. So we store that into 1, and then we store reg 1 into reg 2. Yeah, so we store that pointer into this pointer box. So what happens is, so we do mem to reg, we promote this I32. Yeah, so we promote that. So we get rid of the store. And then what happens is this is a null pointer, I believe. Wait, no, this shouldn't be. Yeah, this is what's happening, I think. Right? Or wait, no, we replace it with. Oh man. Okay, wait, I'm getting lost in my own stuff. We're gonna do this the lazy way, I think. What we're missing right now in our like big check guard box thing, where did this live? Here. We need to check that we need to check that it's the pointer in this store, not the value in the store. I think that's what we need to check. So we want to get value. So what type is this? Yes, that's a value type. So we want to we want to make sure this is not the allocate, right? Because this I believe gets encoded as a use if we're just like sticking the pointer in something. Yeah, I think that is where the problem is coming from, at least. Or something to do with that, at least. We're forgetting to like add a guard somewhere, and I think this is the guard that we're missing. Oh man. So if it is a store, and this value, the value that we're storing is not that. Or wait. So we can do this, and we can do not equals allocate, I think. I think that's what we want. Or we could put this in front. And it's like prettier. Okay, it's uglier. Never mind. We are not doing that. Okay, let's rebuild. And hopefully this stops it from crashing, just by being very conservative. Okay, call chain. Okay, that's still not overly conservative. Let's check putter. Crap. Okay, this is looking really rough. Huh. Add use. Set value. Yeah, this is bonking me over the head, I can't lie. I think we're guarding it correctly now, though, at least. You're invalidating it mid-loop. I think there's a chance that I think there's a chance that, like, something is being deleted before that point, though. Like, if it's an allocate and we've deleted the allocate, then that's also a null pointer. I think that's what's causing it, because I think I've gotten rid of most of the... I think I've gotten rid of all of the, like, iterator invalidation issues, at least. Or I'm, like, kind of confident in that, at least. Where is this again? Like 189, it was like this area? Oh, I guess maybe. No, it doesn't replace uses. Yeah, we make a vector out of it, so it isn't invalidating. We make a vector out of the range. That's the reason we have this mess here, specifically. Which makes me think, that's what makes me think that it's null beforehand, because we're deleting an allocate already. I think this means we need to update replace uses in some way. I think that is the big missing piece. Okay, wait. What does erase uses again? Oh, this is just literally erasing from the list, I see. So replace uses. Yeah, so we're replacing it with the new value. I think... Oh, man. I think we need to, like... I think load is where it's going wrong. I think we need to, like, recursively call replace uses here, because this is just, like, a find replace right now. Oh, man. Wait, what? Wait, where are we calling this? Or what are we visiting? Specifically. Store. Yeah, okay. Yeah, okay. We're gonna need to do some really funky stuff. Oh, and then now we have to add load. Oh. Okay, all good. Real quick, let me check my instruction for load. Store has allocate as a pointer. I guess this needs to be updated at some point. I guess now is a good time. Yeah, that was a little bit of a troll design choice in the past. Huh. Let's get Collies. Okay, let's fix this real quick. Get a little quick win in. Because we are updating that. Let's do that. Okay. Let's see what else this breaks. Because I think this will break a lot of things as well. How's the compiler going? The compiler itself is going well. The thing I'm debugging right now is not going well because I'm like running around an invisible maze, and the maze is of my own creation. Oh my god. Okay, let's just look through the mem to reg file again. Let's add that to Harpoon so I don't lose it again. Okay, let's see. Transform mem to reg. So we just need to change this type, right? Value star. I guess unpromotable should also be. I should just stop using allocate to describe pointers, huh? That's really stupid of me. What type is this again? I can't tell what type that is. Oh, we just have... Wait, no, we can't do that. These are definitely allocates though, I think. I think these are very safely allocates in depths, right? Grr. Actually, yeah, why did I do that? Okay, this... I think these should be allocates. I think those definitely should be. What's wrong with this? Okay, and then let's... Oh, man. I'm trying I'm trying to do a deep dive into how compilers work. I come from a physics background. Ooh. What's the front end, middle end, back end doing a compiler? I'm a little bit locked in right now, so I'm not going to give like the usual really long spiel. The short version is the middle end does optimization. The front end, I guess, takes a programming language and turns it into the optimizer language, and then the back end turns the optimizer language into like the destination language, I guess. What is wrong with this again? So this needs to be an alloc. But we don't know if it's an alloc. Okay, we might just want to make these values and be lazy, huh? Right, obfuscator? I don't really care. Like, I care, but like I don't really care, you know? We want these to be allocs. Or I guess... Okay, let's... Maybe we move this up, actually, instead. This should be unpromotable allocs. Okay, so that's fine. Oh wait, we can just... Wait. What type is this again? We want keys. So we want that, comma blank. Right, we can just do that and get rid of some of this boilerplate. Yeah, and this we aren't, this is just read only, so I don't think that should cause any issues. Actually, we can, what if we just put this in here and save a little bit of space and ruin the readability of my oh, this we actually need. Okay, all good. Oh. This is fine. But it's ugly now. Okay, all good. We saved 2 lines. I think that's worth it. Okay, so let's look at this. So if... so we want... store... alloc, or I guess putter alloc. So this should be... let's do like that. I need to use less dynamic cast. Or like do some sort of like fast dynamic cast thing. Yes, we can do that. So it's not an alloc, then continue. Yeah. There we go. So then what else needs to change? I guess we need this guard here anyway then, huh? Yeah, okay, we'll just yoink that. So let's try this all again. Does that even matter? I guess it does matter, huh? Oh yeah, what the hell? Okay, let's yank that. Okay, that's fine. This we need to... Actually, we could just dynamic cast here, even. Do that. So if it's not an allocate, or we are not promoting it, then what the hell? Okay, I messed up my indenting somewhere, I think. Okay, am I just paranoid now? What the? Okay, I'm having a great time. Anyways, okay. So if it's either not an allocate or it is not promotable, then we skip it. Okay, and then this last case is the load. And then we can steal this again, I believe, right? So if the load get putter, yeah. So I think that's most of the guards we wanted. I think that should be good. Okay, it looks like middle end didn't break, which is a good sign. Front end also didn't break, that's nice. Okay, great. What the fuck? Okay, so this is all in the 2-string now. Why is it in the 2-string? Oh. Okay, so it appears our defaulting has done what we expected. Huh. Huh. I don't think that's the intended behavior, but... Huh. We appear to have skipped some steps somewhere. I think that is what has happened. Let's look at the test again. This is in regression, input, let's look at putter. Well, let's uncomment everything. Let's go nuts. First of all, what happens if we run it without Valgrind? Okay, just full on psych faults. So that's... But if we do this... Aye. That also psych faults. What happened? Okay. Okay, sure. So what happens if we... go to like that? Oh, yeah, let's look at those. Oh wait, this works. Oh, that like very cursedly works. I think some of the wires got crossed somewhere. But, huh. Okay, well, return pointer looks correct in some way. Let's comment this out. If we throw this through Valgrind. Okay, so this was just completely fine. This is like kind of what I was hoping to get out of this. So, what happens if we uncomment that one? Yeah, so like this should not be breaking like this. Or I guess maybe this would be like very much illustrative as well. Let's just look at. Does this work? I think this one was broken as well, right? Yeah, this was like super broken for some reason. So what happens if we do this? Yeah, okay. So somewhere our use replacement is going bonkers. Or like we're deleting something we should not be deleting. Okay. So what does this O0 look like again? I know this is really sloppy. This should just like work properly, at least. I think I think I'm just doing something wrong. I think I'm just doing something wrong. Who could have seen that coming? I think I am just doing something wrong with this like replacement stuff. Or something's getting deleted that should not, or something's getting deleted without being replaced. I think it has to do with load. Given that this is happening here, I think that is exactly what is happening because I have not accounted for this before. Okay, so let's just be simple with this. Get putter equals old value. Let's set putter to new value. We need to add new setters as well for all of these. I imagine we also need to do something similar here. I think that's just as simple as it is, huh? Oh man. Or at least load, we could try this. In case I like forget about this, we'll add the to-dos there. So I will eventually remember and beat myself up over it for forgetting. Yeah, we can do that. And then load also needs that. Yeah, so this is where like the del use add use slop is coming from. And it definitely makes a mess. Maybe I shouldn't have tracked def use chains. That might have been a little bit troll. Anyway, let's do putter. And we can yank that. Let's throw this here. And that's fine. Let's see if this works now. Actually, I think I'm doing this very incorrectly, now that I think about it. But we'll see if this is We'll see what happens. I think we will have some really nonsensical code get printed out, and it's gonna be kind of funny. We're gonna be like loading from a number. So we're gonna need to do a type check at some point. Or let's see what this does. Okay, so that works. Oh. Wait. That actually does what we want. Wait a second. Wait, hold up. Was it this simple? No, we did something wrong. Wait. No, did we? Wait. Because this looks correct at a glance. I think we just deadass forgot to do that. This looks correct. This looks correct. Wait, hold up. And I think this also looks correct. Wait. Why is this correct? Huh. Well, I mean, all this looks fine. We store 0 and 1. We store the putter for 1 and 2. We store putter for 2 and 3. And then we unload yeah. This looks fine, actually. Wait, wow. Holy shit. Okay. Wait. Okay, well, so I guess that kind of worked out, huh? I feel like this shouldn't have worked, though. I thought there would be like some like type issue that would come up, but I guess not. Huh, okay, well. Let's commit some stuff. I think this is correct. Let's make build. And then what happens if we just run it all the way through? Okay, well, we still have some plumbing to do, but we'll figure that out on the way. Let's make build. What do we change in test? I see. Split, deref, and address. Okay, let's add middle end, mir. So here we change allocate in mir, or allocate putters in mir to value star. Add getter for value star for putters. Please be formatted. Okay. And then add source. Let's clear source, middle end, utils, replace usage. Yeah. Here we fix mem to reg to avoid lowering some allocates. And then finally we fix replace uses to also replace putters. Okay. And we push. Okay. So yeah, I think that was really productive. We still have a lot of like plumbing work to do though. So if we go back to the big list of stuff, this is done now, so we can delete that. I think this is fine. We should check that first though, I think. Or we should check that after this. Yeah. Yeah, that's kind of where we are now. Yeah, and we have finished all like the front end stuff for this. So this is all fine. Next time I think we'll just look at the middle end and maybe the back end and just hope everything is fine. Yeah, I'm gonna head out now because I've got other stuff to do tonight. Thank you all so much for showing up today. Let me check if my friend is streaming actually, because I think that might be a good place to go. And yeah, okay, Aiden is streaming. Okay, let me put this in the chat. Yeah, go to his stream. He's really cool. He is the friend that convinced me to start streaming. I would suggest that I would suggest you show up to his stream. Right now he's doing homework for our school's compilers course. So if you're here for the compiler stuff, you should go to his stream. If you weren't here for the compiler stuff, you should still go to his stream. Yep. Anyways, everything else I usually say is like in the description. Check that out. Like, comment, and sub, or maybe don't comment. I don't know how streams handle in YouTube. But yeah, take care, y'all. Take it easy, and I will see you all on Aiden's stream.